In this video, we are going to discuss class 5, which was supposed to have taken place on the 23rd, but due to the weather, it was cancelled. So you simply click on class 5, it will take you straight to class 5. And here now we were supposed to have discussed the review of the construction of the cumulative frequency graph, and how we can use it to obtain the quartiles, the lower, the median, and the upper quartile. Their locations are a quarter N, a half N, and 3/4 N respectively. N will be 85. N is the last cumulative frequency. So as you can see, just a minute, the position or the location on the lower quartile is 21.25, and it was obtained located on the y-axis. That's where you have cumulative frequency. A horizontal line was drawn, the curve was touched, and a vertical line goes downwards towards the x-axis, and that's where you have the variable time. And we found that the lower quartile was approximately 36 minutes. Similarly, the median, its location is 42.5. That's a half by n. N, obviously, is the last cumulative frequency. N here is 85. That's the last number on top there on a cumulative frequency graph. And half of 85 is 42.5. So that's the location of the median. A horizontal line was drawn, also a vertical line downwards towards the x-axis. And the median was obtained to be 42 minutes approximately. Similarly, the location for the upper quartile is 63.75. That's 3/4 times 85. And a horizontal line was drawn and a vertical line downwards towards the horizontal axis, and an upper quartile of approximately 47 minutes was formed. So that's how you obtain the quartiles from a cumulative frequency graph. Now we can use those quartiles now to construct a box plot. As you can see, the box plot was constructed and using the quartiles and the lowest and highest value. The lowest value is 15, that's the lowest boundary, and the highest value is 75, that's the upper boundary, because the data was grouped in terms of intervals. And the median, the lower quartile, median, and upper quartile were obtained to be 46.5, 45, and 50 minutes approximately, or 47, 50 minutes thereabout. Okay, and here the box plot now was constructed, and it appears to be approximately symmetric. Slight skewness towards the right, but approximately symmetric. Now, the use of the box plot now can indicate to us more or less where the median or the mean will be located. Okay, so as you can see, the majority of the values are between 36 and 50. So therefore, there's a high percentage, 90+% confidence that the population mean is around that region between 46 and 50. Okay, so the cumulative frequency graph could not have indicated to us better where the median or the mean is located approximately, but the box plot could do that. And that would help us now to compare this to what the null hypothesis is saying, in order for us to make a decision with regards to the null hypothesis and the conclusion. As you can see, the null hypothesis is saying that the population mean is more than, if not equal to, 40 minutes. And what is the data saying? The data is saying something very identical, that the population mean appears to be between 36 and 50 minutes. Okay, most likely more than 40 or equal to 40. Certainly not less than 40. Okay, because 40 is right down there. So there's a high probability that the population mean and a very low probability that population mean is between 26 and 50, more than or equal to 40. but not less than 40, okay, respectively. So the decision here now would not to reject the null hypothesis. This seems to be an error. Okay, so let us rectify this. It says do reject the null hypothesis, but since that the null hypothesis is basically agreeing with what the data is saying, okay, meaning that the population mean appears to be, if not more than, but equal to 40 minutes, okay, then we must not reject the null hypothesis. So we see not here, do not reject the null hypothesis. So let's make this correction. And the reason why we are not rejecting null hypothesis, because it appears that the population mean is between 46 and 50, which is in agreement with what the null is saying. So we will not reject the null. And on this basis, we can go to the conclusion. Since we have not rejected the null, then it will be the conclusion. So based on the data, the population mean appears to be greater than or equal to 40 minutes. So this was part of what we would have done on Tuesday. Also, we would have ventured into number 34. But before 34, we had to compare the relative sizes of the mean, median, and mode. Since the distribution is approximately normal, then the mean is equal to the median is equal to the mode. Then you have to calculate the interquartile range, which is the upper quartile subtract the lower quartile. That would be 50 minus 36.5. That would give us 14.5 minutes. Then part F, we would have to calculate the percentage or the probability that an athlete completes in less than 45 minutes. So to do that, we have to go back to cumulative frequency graph to see how many athletes complete in less than 45 minutes. And then we have to divide that by the total number of athletes, which is 85. So what we do, we go on the horizontal axis to look for 45 minutes. Okay, and then we trace the vertical line up and across, and we get about 42.25 athletes completing in less than 45 minutes. So the probability would be the number of athletes of less than 45 minutes, which is 42.5, divided by the total number of athletes, which is 85, and then we get the value of 0.5 times 100%, that will be approximately 50%. Then we proceed to calculate the probability of an athlete completing in more than 30 minutes. Okay, so if we have to get a frequency of more than 30 minutes. So to do that, we go on the horizontal axis, we look for 30 minutes, we go up and across, and we found 15 athletes completing in less than 30 minutes. Bear in mind, this is the less than cumulative frequency graph. So the first number we obtain on the vertical axis, we have to interpret it as less than. So 15 athletes completed in less than 30 minutes. So to get the number of athletes who completed in more than 30 minutes, we have to subtract 15 from 85. 85 is the total number of athletes. Okay, and that will give us 70 athletes completed in more than 30 minutes. And we divide this by 85 to give us 0.24. That will be about 82.4% of the athletes completed in more than 30 minutes. Then we will be able now to go to number 34. 34 is concerned about the two variable analysis. The two variables are absenteeism and score. Research question: what is the relationship between the two variables, between absenteeism and score? Okay, and there's a hypothesis saying that, okay, there's a strong negative correlation between the two variables, between absenteeism and score. No. Is that true? That's a hypothesis. That's a proposition, okay, or supposition. All right. So this has to be tested. So data has to be collected. Data was collected to verify if the claimed hypothesis that there is a strong negative correlation between absenteeism and score is true by using a scatter plot. Okay, now the data was collected and it was presented in the form of this table. But using this table to test that hypothesis is very difficult to determine whether or not there's a strong negative correlation with confidence. So we have to present the data again using a scatter plot. A box and whiskers cannot do that for us because a box and whiskers only use one variable. It's a one variable graph. Okay, time, for example, expenditure, okay, on the horizontal axis, only a horizontal axis. Okay, a box and whiskers only has a horizontal axis. Okay, but here we have two variables in play. So we need a different type of graph, and we can use a scatter plot, which has both a horizontal and a vertical axis. The horizontal axis will be represented the x variable, the independent variable. Here it is absenteeism, and absenteeism seems to be having an influence on score. Okay, and so score now will be the dependent variable. It will go on the y-axis, and then we can use this pictorial representation to see whether or not there is a strong negative correlation between these two variables. So this is what we'll be discussing in the next class.